Today we're doing lesson 4.8, Beyond 100,000. On page 137, it says, how many do you see and how do you see them? So who would like to share with me how many you see? They've got one of these, three of these, two of these, and five of these. So how many do you see, Ari? 1,325. Give me a thumbs up if you see I got that same number. Don't erase it if you didn't. Okay, most people got that number. But do you remember a few days ago that I told you that we were zooming in to use these base 10 blocks for decimals? And when we did that, we said these are ones, these are tenths, these are hundredths. So that would make this guy what? Davis? No. That's what it is now. Or that's what it always has been.
10,000.
No. So Avis, if these whole things are one whole.
And that's 10 holes.
10 holes, right? Okay, so if you saw these as this was one hole, this was tenths, this is hundredths, you would have got a different number. So 5 little tiny hundredths, 2 tenths, then our decimal point, 3 holes, and then because this guy is 10 times as big as this would be a 10, okay? Either one is correct. It just depends on how you saw it, okay? Most of you, when you see a picture like this, you think 1,325. I do too. But the point of today's lesson is to realize that we can use these blocks to represent different things, different numbers. Okay? So, now let's move to the next page. Let me see what I did with my pen. Here it is. Okay. Says Lynn is using blocks like these to represent 15,710. Okay, so I've set this up where I've got 1, 2, 3, 4, 8, 12, 13, 14, 15 of these. Then I've got 7 of these, and then I have 1 of these. So in that situation, to make 15,710, she would need, that's what she would need to make that. It says, what about if we changed the value of each of these cubes? What if instead of using this as a 10, she wants to use this as a 10? Let's say that she does this, guys, because she doesn't have 15 of these, okay? She only has 1 in her set. All right, you with me? So what we're gonna do is we're gonna see what she would need to do if she were to not have enough of these. She's going to change the value so that these little guys become 10. So I'm going to write this up here. So now, nope, I got it. This is the one that I can move that one the easiest, but the others I can't. Okay, so here's the new values. This guy, or this little guy is going to be 10. If this little guy is 10, what would this one be? Jackson? 100. What would this one be? Autry? 1,000. And then what would this one be? Avis?
100,000.
Nope.
Wait, no, 10,000.
10,000. All of them are 10 times bigger than the one before, right? So look, we just increased the zeros by 1 each time, okay? Remember how you can replace the word, or replace 1 0 with the word 10? So we just made them bigger by 1 0 or 10 each time, okay? So here we go. The long block would be worth 100. Write this down on your paper. The large, and we're talking about this guy would be 100. The large square block would be 1,000. And the large cube would be 10,000. Okay, you guys get all that? All right. Next page. Use Lynn's strategy to represent 15,710. So, how could we make 15,710 if these are our values? Okay, so how many of the 10,000s would we need? How many of these big guys would we need? Haziel? 1. Okay, because what digit is in the 10,000s place? A 1. Okay, so we would need 1 of the large cubes. Okay, how many of these thousands would we need? Zerelda? 5. Because what digit's in the thousands place? A 5. Okay. How many of these hundreds would we need? Colton?
7.
7. Because the digit in the hundreds place is 7. And how many of these little cubes would we need, Olivia? 1. Because the digit in the tens place is a 1. So exactly what I just wrote right here is what you need to write on number 3. So you need to make a big cube. And then times 1, and then a square times 5, and then a long skinny one times 7, and then a little square times 1. Okay, so that's what we need, and that will make 15,710. Next, they want us to use Lynn's strategy to represent each of these numbers below. So the first number that we need to represent is 23,000. 23,000. So let's start with the big cubes. Remember, the big cubes are valued at 10,000. So how many of the big cubes do we need? Athena?
2.
2, because in the 10,000s place, there's a 2. How many of the 1,000 cubes would we need? Cameron?
3.
3, because the digit in the thousands place is a 3. We wouldn't need any of the other ones because we've already, those two together, this would be 10,000, 20,000, plus 3 would be 23,000. So, on this one you need to draw one big cube, and then times it by 2, and then one of the squares and times it by 3. Okay, next we have to make 58,100. Okay, so 58,100. Okay, if we were going to do that, how many of the big 10,000 cubes would we need? Todd?
5.
5, yes, because in our 10,000s place is 5. Jackson, how many of the squares? 8, because these are thousands, and that's an 8 in the thousands place. How many of these long ones? Devin?
1.
1, because in the hundreds place there's a 1, and that's it. So we're going to draw one big cube, times it by 5, one big square, times it by 8, and one long, times it by 1. All right, one more to do. This time we have the number 69,470. Okay, Olivia, how many of the big 10,000s will we need?
6.
That's right, 6 of those. How many of the thousands? Emma? 9, that's correct. Harbor, how many of the hundreds?
4.
Yep, because in our hundreds place we have a 4. And how many of the little tiny cubes that are worth 10? Fisher?
7.
7. Very good. Okay. So now we're going to do a big cube times 6. A square times 9. A long times 4. And then a small cube times 7. All right. Next page. Oh no, still. That page, or this says, using her strategy, which base 10 blocks would you use to represent 100,000? Okay. I want us to figure out how many of each we would need to make 100,000. Okay, so if we start with the big 10,000s, how many of the 10,000s would you need to equal 100,000? Haziel? 10 of them. So we would need 10 of these because 10,000, which is the value, times 10, let's see what that equals. What is 1 times 1, guys? 1. And And then 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So that means 10,000 times 10 equals 100,000. Now what if we don't have any of these? How many thousands would it take to get 100,000? Mary? 100. These are 1,000 and we're trying to make 100,000. So we need 100 of the thousands. Okay? Now watch this. 1 times 1, 1. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So we would have to use 100 of these. How many of these, which are worth 100, would we need to make 100,000? Colton?
1,000.
1,000. We would need 1,000 of these 100s. 100,000. Okay? So if that's worth 100, we would need 1,000. 1 times 1 is 1. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Zero's got a match. Do you see a pattern? Okay, and last, how many of these little tens would we need to make 100,000? Zerelda?
10,000.
10,000, yes. Because 1 times 1 is 1. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So we would need 10 of these, 100 of these, 1,000 of these, 10,000 of these. There's some patterns there, right?
Mm-hmm.
Avis, what do you see?
So the first number, so like if it's 100,000 times 10, it's the exact opposite of that.
So
10,000, 10, 1,000, 100, 100, 1,000, 10, 10,000.
yep, so these flipped, right? 10,000 times 10, 10 times 10,000. 1,000 times 100, 100 times 1,000. So they flipped, didn't they? They just changed places. Fisher?
I noticed that on the 10,000 times 10,
Uh-huh.
you can take the 0 from 10 and put it in the 10,000 and it'll be 100,000 times 1.
Exactly, exactly. You can move that 0 over and then it just becomes 100,000 times 1. You can actually do that with all of them, Fisher. You can stick these zeros over here and then it becomes 100,000 times 1. Zerelda?
I noticed that you just move like the 10 over to 10,000, the 100 over to 100,000.
Mm-hmm.
and
Pretty cool, right? So this
the
is what I...
1,000 over to the...
All right, have a seat. Okay, I want you to write this down. Okay, so here's what I want you to write down. We would do...
Is that okay?
Yeah, that's fine. Okay. Write this down. So these are 1,000. So we're gonna write, or 10,000, sorry. So 10,000 times 10 equals 100,000. And then on this one that is worth 1,000, we multiplied by 100 to get 100,000. Get this written down if you haven't already. And then on the long ones that are worth 100, we multiplied times 1,000 to get 100,000. And then these little small ones, which are worth 10, we multiplied times 10,000 to get 100,000. So those are the different ways that you can make 100,000 using these alternative values.
There's so many zeros.
So many zeros. All right, so we need to keep going. It's right here. Okay. What number is represented? Okay, so in this picture, it says a small cube represents one whole, which is what you're used to. What value do the blocks in the picture represent? So there is 5 of the little ones, 2 of the 10s, 3 of the hundreds, and 1 of the big thousands, right? Now it says a small cube is now worth 10. So if this is worth 10, and we have 5 of them, what does 5 tens equal? Autrey?
50.
50. So I'm going to put a 50 right there. And then we have 3 of these, which are now hundreds. So that would be 300. No, sorry, we have 2. Back up. We have 2 of these hundreds, which means there'll be a 2 in the hundreds place. And then we have 3 of these, which are thousands. So 3 thousands. And then we have 1 of these, which is a 10,000. So a 1 goes in the 10,000s place. Now look at those 2 numbers I've just written down, which you have not. 1,325 or 13,250. What's the only difference in those numbers? Athena?
One has a 0.
Behind it, right?
Yeah.
One has a 0 behind it. So when we took this, which started out to be 1, and we made it 10, we put a 0 behind it, right? That shoved everything else forward, right? So so on your assignment today, you're going to have a similar question to this. And just think, all you got to do is add a 0 because we just made everything 10 times bigger. And when we multiply by 10, it's like multiplying by 1 and adding a 0 behind it. Okay? All right. Write 2 statements comparing the numbers in the previous problems. Let me see where we're at. So 2 statements we're going to write. We're actually going to skip this one and come back to it. So for now, go ahead and go to the last page. We're going to come back to that in a minute. Okay. It says to represent large numbers, Lynn changed the value of a small cube to 10. She used the following blocks to represent her first number. So first, she has 3 of these. And they're all worth 10, or they're worth 10 each. So what would that be? Devin? These are worth 10s. And there's 3 of them.
13.
Nope. Count by 10 3 times.
15.
10, 20,
30.
30. There you go. Decompose. Okay. So we're going to put 30 down. Then she has 8 of these, which are worth 100. What does that equal, Jackson? 800. So we're going to put an 8 here, which is in the hundreds place. And then she has 9 of these, which are worth 1,000. Athena, what would that equal?
9,000.
9,000. So we put a 9 in the thousands place. And then she has 4 of these, which are 10,000. So what would that equal? Haziel? 4 10,000s. So she's got 10,000, another 10,000. What would that be? Hang on, 20, then another one. 30,000, then another 40. So we don't need to write a 40 because the place is the 10,000. So 49,830. Then it says write an equation to represent the value. So what did she add each time? So first she had 4 of these, which would be 40,000. Write this down. 40,000 plus, this is kind of like writing it in expanded form. 9 of these, which are each worth 1,000, so that would be 9,000. Then 8 of these, which represent hundreds, so that would be 800. And then 3 of these, which are worth 10. 30. And all together, when we smash it all together, it's 49,830. Okay? One more of those. Same deal. Okay, so she's got 5 of these that are worth 10. What would that be? Harbor? 50. So we're going to put 50 in the back. And then 4 of these, which are worth 100. Ari? 400. So we're going to put a 4 right there because that's the hundreds place. And then she has 20 of these, which are thousands now. Jackson? 20,000. Now, if I put a 2 right here, does that say 20,000? No. No. So I gotta put a 0. Gotta put a 20, an actual 20. And then she has 10 of these 10,000s. 10 10,000s. On the previous page, we figured out that 10 10,000s equal 100,000. And I don't need to write 100 because I was already in the 100,000s place. So I'm going to put that right there and then stick in my comma. Okay. So now we got to split it out. So 100,000 was our biggest number. Cameron. Okay, you're whispering. Okay. 100,000 plus 20,000 plus 400 plus 50 added together equals 120,450. Okay, now we're going to go to that question on that previous page and then we'll be finished with the lesson. On the previous page, the question was, to write 2 statements comparing the numbers in the previous problem. Let's see. So here's what I want you to write down. When the small cube represents 1, the value is 1,325. When it represents 10, the value is 10 times bigger at 13,250. So that'll be the last thing, and then your practice page will be 154.